In this example, we're solving the equation 2 times the difference of x and 5 squared plus 1 equal to 9. So when we go to solve this equation, first thing to notice is that our x here only appears one time. And because x only appears one time, we can use reverse order of operations to solve this equation. So please excuse my dear Aunt Sally. We'll start by getting rid of any addition and subtraction outside the parentheses. So we're going to work with everything outside the parentheses first, and then get rid of the parentheses. I like to think of it like eating a peanut. You have to get rid of the shell first, and the stuff outside the parentheses is the shell. So I'm going to get rid of the addition and subtraction that's outside the parentheses first. So I will subtract 1 from both sides, leaving me have 2 times our x minus 5 in parentheses squared equals 8. We still have more stuff outside parentheses, so I'm next going to get rid of the multiplication division that's outside the parentheses. So this 2 here, I will divide both sides by 2, leaving me with the parentheses of x minus 5 squared equals 4. Now I still have one thing outside parentheses, and that's my exponent. So to get rid of the exponent property says that if we have x minus 5 squared equal to 4, then x minus 5, our variable, will equal either plus or minus the square root of 4. In other words, x minus 5 equals plus or minus 2, because the square root of 4 is 2. To finish it off, though, unlike when there's not parentheses, when there's parentheses, we have extra stuff to do after getting rid of them. So we can't leave the plus minus sign usually like it is here, and instead we are going to separate into 2 separate equations and then just finish it off that way. So x minus 5 equals 2 and x minus 5 equals the negative 2, and just finish each equation separately. So add 5 to both sides, and x will equal 7 as one of the answers, and add 5 to both sides, and x will equal positive 3 for the other answer. There we are. This example asks what are the solutions to the equation the difference of x and 2 squared plus 1 equal to 25. So if I go and solve this one, since x only occurs once, I can use reverse order of operations. So we'll start by getting rid of anything outside the parentheses, starting with addition and subtraction. So we have a plus 1 outside the parentheses, so we will subtract 1 from both sides, giving me x minus 2 squared equals 24. Now, according to the property with exponents, if we have something squared equal to a number, then, in our case, x minus 2 squared, then x minus 2 is equal to plus or minus the square root of 24. Now, 24 is not a perfect square, so we're going to have to break down the radical, because during this unit we are only looking at exact answers. So the biggest perfect square that goes into 24 is 4, and it's 4 times 6. So we can rewrite this as x minus 2 equals plus or minus, the square root of 4 is 2, and we can't square root 6. So we have x minus 2 equals plus or minus 2 square roots of 6. Now, previous examples, if there wasn't the radical, or if there's not an I would separate it into 2 separate equations, because I would be able to combine this 2 after moving it over with what's there. But because of the radical, I won't be able to actually combine the 2, so I'm not going to separate it this time, and I'm just going to finish it off as is. And I'll add 2 to both sides here. But again, we can't actually combine that 2 with anything, so it would just be x equals plus or minus 2 square roots of 6, with the plus 2 tagged on, or more commonly you'll see it written as x equals 2 plus or minus 2 radical 6. So more commonly you'll see this out in the front. And do remember that the plus minus means that there's actually two equations here, or two answers here, 2 plus 2 radical 6 and 2 minus 2 radical 6. In this example, we're supposed to write the equation x squared plus 8x plus 5 equal to 0 in the form of the sum of x and p squared equals q by completing the square. This is essentially the format that it looks like after we do just the completing the square steps. So to start off with, we usually want to make sure our equation is in standard form in order to follow the steps properly with how they're typically written. But that's not always necessary. You just need to make sure x squared and x are on the same side, and that's good enough as far as getting it started. The first step in completing the square is to divide all the terms by a, which is the coefficient with x squared. In this particular problem, there is no value for a, or the value is 1, so we don't have to divide by anything. The next step is to move the c term, or c over a if you actually divided by a, to the other side. So I'm going to subtract 5 on both sides. Give me x squared plus 8x equals negative 5. Now is really the key step in the completing the square process. We need to calculate the number that will actually make this side a perfect square so that we can factor it using the factoring pattern. So in order to do that, what we'll do is we'll take the value for b, we'll divide it by 2, and we'll square it. If we add that number to both sides, we'll be able to factor the left side as a perfect square. So in this case, our value for b is 8, so I'm going to take 8 divided by 2 and square it. 8 divided by 2 is 4, and 4 squared is positive 16. Should always be a positive number. After all, we are squaring it. So we're going to add that positive number, 16, to both sides. So plus 16 and plus 16, which is going to give me x squared plus 8x plus 16 equals, on the other side, 11. Now the next step is to factor this expression here. Now assuming you did the last step right, this should be a perfect square trinomial. According to the formula or pattern for it, if we have a squared plus minus 2ab plus b squared, its factors are going to be a plus minus b squared. So in other words, because we did this process to complete the squared, if we go through factoring it, our factors are going to be the square root of that first term, which is just x, the square root of that last term, which is 4, and we'll end up keeping the same sign as what our middle term has. So we'll keep plus. So this will factor into x plus 4 in parentheses and squared. And we have the equals 11. So this ends the problem because we are now in this format where we have a perfect or a binomial squared equal to a constant. And that covers the steps for completing the square. Okay, in this example, we're going to be writing the function y equals x squared minus 20x plus 8 in vertex form. Now, the way we go from standard form to vertex form is we use the process of completing the square. So if we start off with our equation, the first thing we would do is divide all the terms by a, but we again don't have an a here. So our next step will be to move our c, or c over a, term to the other side. So we'll subtract 8 from both sides. If we do this, y minus 8 we can't actually do, so it's just going to stay y minus 8 equals our x squared minus 20x. Our next step here will be to go through and calculate our b over 2 squared. We need to know what we need to add to both sides so that the right side here will be a perfect square trinomial. So our value for b this time is negative 20. Remember, in standard form, b is the coefficient of the x term. We'll divide that by 2, and then we'll square it. So negative 20 divided by 2 is negative 10, and negative 10 squared is positive 100. Should always be a positive number because we're always squaring it. We're going to add positive 100 to both sides of the equation. So that's going to give us y plus 98, or 92, equals x squared minus 20x plus 100. Now we just have to factor. This should be a perfect square trinomial. Therefore, the factors will be that square root of the first term, so x, square root of the last term, 10, same sign as the middle, so x minus 10 in parentheses squared will be the factors. We'll have y plus 92 on the left side. Now, in order to finish getting in vertex form, y does need to be by itself. So I'm going to just solve this for y. I will subtract 92 from both sides. Since this 10 is inside the parentheses, I can't actually combine the 10 and the 92 due to the fact that there's an exponent around that set of parentheses. So I'll end up just tagging on the minus 92 to the end after the parentheses, leaving me with x minus 10 in parentheses squared minus our 92 as the final answer for this equation in vertex form. In this example, we're going to be solving the equation by completing the square. So to do it, we have to first start by going through the completing the square process. So I'm going to go ahead and rewrite my problem. The first step in completing the square is to make sure to divide all the terms by a. We don't have an a in this example, but that's where we would normally start. Well, we do have an a, it's 1. But we don't need to divide by 1. So the next thing we're going to do is move c over a, or in our case, just c, to the other side of the equation. So we'll subtract 3 from both sides, giving me x squared minus 2x equals negative 3. Now, we're going to have to complete the square. This is the big part of this process. We're going to take our value for b, we're going to divide it by 2, and we're going to square it. And that's what we're going to have to add to both sides of the equation. So our value for b this time is negative 2. So we're going to take negative 2, divided by 2, and square it. Negative 2 divided by 2 is negative 1. And negative 1 squared is positive 1. So we're going to be adding 1 to both sides of the equation. So we have x squared minus 2x, adding 1, plus 1. And then equals negative 3 plus 1 is negative 2. Our next step is to factor this expression. However, if you completed the square, you can use the pattern. If you did it correctly, it should work out. So it's just going to be the square root of that first term, which is x, the square root of the last term, the square root of 1 is 1, and then keep the same sign as what you had in the middle, so minus 1, and there we go. That should be the factors, assuming we did the completing the square part right here correctly. That's the whole point of this process, so that factoring works out the way it does. Now since we're solving this equation, we just have to go through and finish solving. So we first need to get rid of anything outside the parentheses, which is just the exponent. Since we have x minus 1 squared equal to negative 2, that means x minus 1 is equal to plus or minus the square root of negative 2. Negative 2 is not a perfect square, so we would have to break the radical apart. It is negative, so we would separate it into negative 1 times 2, meaning that x minus 1 would equal plus or minus the square root of negative 1 is I, and the square root of 2 we can't actually do, so I'm going to leave it as the square root of 2. We're not quite done. We still have to get x by itself. So to finish it off, we will add 1 to both sides, And we can't combine this 1 with anything, so we'll probably write it as x equals 1 plus or minus I square roots of 2. They'll usually write that number out in front of the plus minus sign. And there we have it. Okay, so in this example, we're going to be solving the equation 2x squared minus 5x plus 1 equal to 0 by completing the square. In order to do this, actually, I'm going to start by rewriting the problem. The first thing that we'll have to do, according to the steps for completing the square, is to divide all of our terms by a. In this case, our a is 2, so we're going to divide all the terms by 2, which is going to give me x squared minus 5 halves x plus 1 half equal to 0. The next thing I'm going to have to do is to move my c term, or my c over a term, to the other side. So I'll subtract 1 half from both sides, which is going to give me x squared minus 5 over 2 x equals negative 1 over 2. Now comes the important part for completing the square, the b over 2 squared. This is the actual completing the square part of this process. Unfortunately, this time our b is a fraction, so it's not as pretty as it was on other examples. This time our b is negative 5 halves, so we have negative 5 halves divided by the 2 from the formula and squared. If we simplify the stuff inside first, when you divide fractions, we have to keep change flips, and negative 5 over 2 times flipping the bottom fraction to 1 half, which is going to give me negative 5 over 4, just multiplying straight across the top. Now we haven't taken care of the squared, so I need to do that now. If I square the fraction, when you square a fraction, just square the top and bottom, which will give me positive 25 over 16. So what I'm going to be doing now is adding positive 25 over 16 to both sides. Adding positive 25 over 16 to both sides. So on the left side, we're going to have x squared minus 5 halves x plus 25 over 16. On the right side, I need a common denominator to add it, so I'm going to just do that quickly off to the side. So we have negative 1 half plus 25 over 16. The common multiple between 2 and 16 would be 16. So the second fraction doesn't need change, but the first fraction I'll have to multiply by 8 if I'm doing common denominator here. So negative 8 over 16 plus 25 over 16, which gives me 17 over 16. So that is what we have on the other side of the equation. There we go. Now we can do the factoring part. Factoring is next. If you did the completing square part correctly, this should follow that pattern where we're just going to square root the first term, square root the last term, and when you square root a fraction, you just square root top and bottom to give me 5 over 4, and then keeps the same sign as what's in the middle, so minus squared equals our 17 over 16. So there we have the factored version. Now we are on to the solving part to finish up this example. So I'm going to slide it up a bit here and then just go ahead and solve. So the only thing outside the parentheses is the squared, so I'll just apply the property with the exponents there. So if we have x minus 5/4 squared equal to 17 over 16, then x minus 5/4 is going to be equal to plus or minus the square root of 17 over 16. I'm going to break the radical down or simplify the radical off to the side. When you square root a fraction, you square root the top and bottom separately. Unfortunately, 17 is not a perfect square, and there are no perfect squares that go into it, so we can't really do anything with the 17. However, the 16 on the bottom, 16 is a perfect square. The square root of 16 is 4. So the square root of the fraction 17 over 16 simplifies into the square root of 17 divided by 4. We just have one more step to get x by itself, and that is to add 5/4 to both sides. Oops. Add 5/4 to both sides. And once again, we can't really combine anything with this. So our final answer would be, let's see, x equals 5 over 4 plus or minus the square root of 17 over 4. Or you may see them write as one fraction, since the two fractions have a common denominator already. You may see it written as x equals 5 plus or minus the square root of 17 over 4.